Hi guys, and welcome back to another lesson in Algebra 1. This is Unit 4, Lesson 7, and we're going to be talking about direct variation. And so our objectives for today is I can identify direct variation from data tables, equations, graphs, and word problems. So we can have direct variation in 4 different ways. And then we can write and solve direct variation ratios and equations. So what does that look like? Okay, so when I made this, I put direct variation in the center, and we're just going to kind of radiate in all these different ways that we can see direct variation. So let's look at this first one. Let's look at equations. Alrighty, so first, we're going to have a constant of variation. This is a ratio, okay? And so this equation is k equals y over x. And it's the same y and the same x that you're used to. It's just a ratio of y over x. And the direct variation equation is written as y equals kx. And so as we go through this, you'll realize that this is a special kind of type of slope-intercept equation where it's going through origin. So the y-intercept is 0, which explains why you don't see, like this part here where we'd have like plus b if it were a y, if it was a regular, let's see, y equals mx plus b, we'd have this here. Well, if it's plus 0, that drops away. So hopefully that will become clear in a second. Let's look at it with data tables. And so let's take some notes about that. So all points must have a constant ratio. So what do we do in this case? We are going to take this particular ratio here, y divided by k, and we're going to do that for all of these. So y divided by k, so we can do 3 over 1. That gives me a ratio of 3. When we do y over k in this case, it's 6 over 2, which gives me a ratio of 3. 9 divided by 3 is also going to give me a ratio of 3. So we're dividing each one of these pairs, and you'll see that in this particular case, every time we divide it, it's giving us a ratio of 3. So we can see all points have a ratio of 3. Okay, they have a constant ratio. Now, if it's not a direct variation situation, you would see different ratios in that data table. Like maybe one is 3 and one of them's 2.5 and one of them's 6. That would be a situation where it isn't a direct variation set of data. All right, let's look at our third type here. And so our third type, we're going to look at a graph. And so all the lines must pass through here. They must pass through origin. Okay. Direct variation are special lines that all pass through origin. Okay. Because they pass through origin, origin is 0, 0. My y-intercept equals 0. So if we wrote this in a regular, slope-intercept equation where it's y equals mx plus b, my y-intercept is 0, which means that portion just drops out. Okay, so that portion drops out. So we get this y equals mx. And then because we're going to make it a little fancier, I guess, they call it like this. This is the equation. But it's the same, it's just a special case of our regular slope-intercept equation. All right, so what does this look like when it is a word problem? So we're going to create a ratio. So let's read through this and see what's going on. All righty. Let's grab that and that. Okay. The distance that a cyclist travels varies directly. This is going to let me know that this is going to pass through origin. It's going to form a ratio, so we can depend on these ratios. So it varies directly with time. If a cyclist travels 12 miles in 2 hours, how many miles will it travel in 7? Well, I can tell you because this is ratios. This is something that you would have done in 7th grade math. And we're going to end up making this where it's y over x. My y is going to be my miles. And my x is hours. Why am I writing it this way? Because I want to make sure that I am setting this up. Both fractions I want to set up in this way, miles over hours. So I'm going to get my first one. We got 12 miles and it's in 2 hours. Okay. And so then it says how many miles? Well, look, my miles is on top. So we don't know what this is. We can just write y there. Will it travel in 7 hours? Okay. And 7 hours is going on the bottom. That's just how I decided to set up my ratio here. All right. So we are now free to butterfly this thing and cross multiply. So we're going to get 12 times 7 equals 2 times y. 12 times 7 is going to give me 84 equals 2y. We're going to divide by 2 and divide by 2. And so we get y equals 42. So the answer is going to be 42 miles. Okay. Alrighty. So let's go to the next problem. Let's go down here. So a direct variation is a linear relationship where the two variables change together at a constant, I guess I could write this a little bigger, at a constant rate. Okay. And it's going to be a constant ratio between all x and y values. It will be consistent if it's a direct variation situation. The constant of variation is called k. And this k is really just a special type of slope. There's nothing magical about it. There's nothing weird about it, really. It's just a particular type of slope. Okay. In the equation, y equals kx is just y equals mx plus b when the y-intercept is 0. And I tried to show you that above, because when your y-intercept is 0, this part just drops out. And so you get y equals mx, but because they thought, oh, you know what, we're not going to call slope m anymore. We're just going to call it a special type constant of variation, and we're going to call it k. So they put a k there. So it's y equals kx. Okay, so let's erase that right real fast. And if I am going too fast, definitely feel free to, pause it so that you can catch up, because I don't want to go too fast for you. All right. We can have this question right here where it is asking, is this direct variation? If so, identify k. Okay, we got a fundamental thing that must happen. It must pass through origin, which means if it passes through origin, the y-intercept is 0, okay? This plus b part, it would be like plus 0. So if this passed through origin, it would be written like this. Just y equals 2x, because if it passed through origin, the y-intercept would be 0. Well, it's not 0, it's 4. That's a situation, okay? So because it has a y-intercept, is not 0. This is not direct variation. Okay, and so there is no k in this case. So we can just write none or na, you know. There's not any direct variation in this case. So let's look at it when they're going to give us a ratio, like what you would have done in 7th grade. And ratios are super fun. We like ratios. Okay, the value of y varies directly with k. If x equals 4 when y equals 20, what is the value of x? So what is x when y equals 35? Okay. Remember, it showed us this ratio. We're setting it up like this. We're doing y over x. Okay. So we're going to come down here, and everything that I'm going to write is going to be y over x. It didn't tell us any other information about it, like units or anything like that. So that's kind of fortunate. We can just put let's see, let me write in a different color. We can just put our y over x. So my first fraction that I'm going to set up, I'm going to pick my y, which is this 20, and the 4 that goes with it. So if x is 4 when y is 20, we know those two numbers go together. What is x? Well, x is on the bottom, right? So we can put x here when y equals 35. Alrighty, so now that we've got that set up, we can simply cross multiply. So we get 20x equals 4 times 35. And you know what? I'm just going to go ahead and grab my calculator because I can. I'm going to do 4 times 35, and that's going to give me 140. Okay, so we're going to divide by 20, divide by 20, and we're going to get x equals 7. So what is the value of x when y is 35? It's going to be 7. That's a proportion like you did in 7th grade. We like proportions. All right, this question is asking, is this direct variation? Okay, now here's the catch. If it is direct variation, we are going to have a constant ratio. Okay, and so remember we did this up here where we divided the y divided by the x, and we got a 3, and the y divided by the x, and we got a 3, and the y divided by the x, and we got a 3, and all of these were 3. It was a constant ratio. That meant that it was a direct variation. We're going to check this down here to see if this is a direct variation. And so we're going to make a ratio out of all of these. Okay, so how we solve this, let me just go ahead and make myself a little note here, is I am going to check the ratio of all points. That's what I'm doing. Okay, and so when I do that, I'm doing y over x. Okay, so if we do 6 divided by 1, so I do 6 divided by 1, that's going to give me 6. 12 divided by 2, so my y divided by my x, 12 divided by 2 is going to give me 6. 18 divided by 3 is going to give me 6. And 24 divided by 4 is also going to give me 6. So notice my ratios were all 6. Okay, so yes, this is direct variation. Okay, so that is one part of my answer. Because it asked us to say, you know, is it direct variation? So that was the first question that it asked, right? And then the second part is if so, identify K. Okay, well, K is just the ratio. That's all it is. So when we look up here, my constant of variation, it's just that. Okay, so let's see, my K is 6. Alrighty. Life is good. On we go. Okay, let's look at this one. It says the amount of money earned varies directly with hours earned. Okay, so money earned varies directly with hours earned. This is telling me this is already a direct variation problem. And so we can use proportions. That's what that is telling me. This part, this varies directly. It's telling me that we know that this is a constant ratio and we can use it to figure out how to solve this problem. So it says if Jordan earns 48 in 6 hours, how much will they earn in 9 hours? Okay, remember our ratio that we write is this guy here. It is this y over x over and over again. That's what we're writing. Okay. So I am simply going to write y over my x, but I need to decide what it is. Okay, so my y is going to be my money over my hours. Okay. Why is hours my x? Because hours, time tends to be an independent variable, and independence variables tend to be x. So I'm going to do money per hour. And that also makes sense if you think about a rate. You know, we talk about earning money and money per hours worked. We don't talk about hours per money earned. Like that is a little backwards sounding. Okay, so I'm going to put my money on top. So I'm going to put 48 over 6 hours. Okay, so I do 48 over 6 hours. So how much they will earn, that is my question, right? We're talking about this part here. They're asking how much, because that's my money, will they earn in 9 hours. So I'm going to put that in my denominator. I'm going to cross multiply. So I get 48 times 9 equals 6 times y. I'm going to need to grab my calculator so I can just offhand solve this real fast. We got 48 times 9. 48 times 9. And we get 432. So we got 432 equals 6y. We're going to divide by 6 on both sides. And there's no shame in our game grabbing our calculator. That's why we're allowed to use it. Okay, so we're going to take that 432 and we're going to divide by 6. And that gives me 72. Okay, so my y is 72. So what is my y again? My y is money. Okay, so I'm going to go put my dollar sign with this. So it was $72 earned in 9 hours. That's how much they made. Okay, so units do vary, and we want to make sure that we understand exactly, what it is that we just calculated. We calculated dollars. All right, so is this direct variation? That's our question here. Is this direct variation? Well, anytime it is a graph, we're going to look to see, did it go through origin? So let me just remind you what we had up here in our notes. The line must pass through origin, and origin is right here. Okay, do we see this passing through origin? No, it's not passing through origin. So this is not direct variation. Okay, it did not pass through origin. Okay, now we don't have a k. There's no constant of variation here because it's not direct variation. And then, we don't have to worry about writing the equation because I said to only write the equation if it was direct variation. Alrighty, last but not least problem. Okay, now this one I want you to see, boom, it passes through origin. So yes, this is direct variation. Yes, this is direct variation because it passes through origin. And then it asks us to find k. And we're like, well, I don't remember how to find k, you know? Well, let's look back and let's go look at our notes up here. What did it tell us k was? K is just a special type of slope. Well, we know how to calculate slope. So we can look at this. Okay, I'm going to pick this point because it passes the hash marks exactly, and I can pick this point. And so I can see that I'm going to go up 1, 2, 3. So it went up 3, and then it hopped over 1. So my k is going to be 3. Now we need to write our equation. Well, how do we know what equation to write? So let's go back and let's look at see what the equation is. Okay. So our equation, it said, is this guy. It's y equals kx. We just found what k is because we found the slope, right? So we know what k is, so we can take this equation and substitute k into it. So let's see. Let's go write it down. If this is the basic equation, y equals kx, I can take this 3 and I can plug it in for k. And all we have to write down is y equals 3x. That's my equation. That's it. That's all there is to it. You know, and because it passes through origin, let me just point out, if we wrote it this way, it was passing through origin. This plus 0, that drops out, right? That's why you can write it as just y equals 3x, because it passed through origin. So origin 0, the 0 drops out. I hope that helps, guys. Until next time, bye.